It's working.
You folks see my screen?
Mm-hmm.
Okay, perfect. So, excellent. Let's see. Let's give a few more minutes to everybody else.
Yep.
We are live on YouTube now.
Excellent, excellent. Super cool. Super cool. Let me just crop a couple more minutes. Wait for everybody to get in, and we will have a go, I would say. Oh, Jules, can you give me a comms check just to be on the safe side here? A couple more minutes left to go, and we'll kick it off. See what happens.
Yes.
Excellent, excellent. Okay, thank you. I was afraid by myself, so.
All by myself.
No, how it goes.
You can sing, and then folks will complain, and you know that.
I didn't make it through exactly with the singing career, so it wasn't my thing. So let's see.
I was thinking that we should know some meerkat jokes.
Meerkat jokes, okay.
Yeah.
You have something in mind?
No.
No? Okay. Me neither. I was just wondering what would that be.
Yeah, I thought it would be good, when we are waiting for the webinar to start, and
Yeah.
instead of dancing, we could be sharing sad jokes or dad jokes.
I just Googled that and I found some jokes.
Oh, do share.
What do you call a meerkat with a carrot in each ear?
What's that?
Anything you want as he can't hear you.
Oh, wait.
There's more, but I'll just share the link with everyone.
Excellent. Okay. All right. So I guess we're going to kick off this webinar laughing, right? So I'm going to start on laughing.
That's good.
Indeed. As long as it doesn't finish crying, that's all. I know. All right, let's just give one more minute. Let's see if somebody else wants to join, and then we can kick it off. All right. Well, in that case, I think we can kick it off. Jules, if that's all right with you, of course. So let's see.
Sure.
And we'll move on, and we'll see how we progress and how many good things we can do today. So welcome to this webinar, everybody. It's about detect lateral movement in Microsoft environments with Suricata, part 2. this is a open source and free to develop run Suricata, run by OISF, is a non-profit organization. Therefore, any funding goes directly to supporting the roadmap. Development is funded through contributions from world-class security organizations of the open source Suricata, Suricon sponsors, and consortium members as well. You could please always support OISF and Suricata, as it's open source and done in good faith, defensive blue teamers software. And one way to do so is actually if you come and meet us, meet the team, support our community, join everybody us at Suricon, which is a yearly conference, this year on-site or virtually in Athens. So basically talks from leading security experts on network threat detection, security, community discussions, so Suricata use, troubleshooting and more, like community brainstorming sessions with on Suricata's development roadmap and similar. Another way to find us always online is the forum.suricata.io, and you can basically connect with the OSF development team or users or anybody that's actually using Suricata and start interesting discussions or gather feedback and experience of how somebody has actually solved a problem. Very good place to bring questions, ideas, breakthroughs, and similar. That's the place where we dwell. A little bit of word about me. My name is Peter Manev. My Twitter handle is Pevma. I'm about 12 years now with Suricata. Part of the OISF exec team. I also help a lot in terms of QA and trainings with the OISF, with the Suricata team. I am also one of the co-founders of Stamos Networks. I maintain the Selks open source distribution, which is based entirely on Suricata. I like things like threat hunting and diving into a lot of data to make improvements for Suricata or do QA things. Now, talking about Suricata, a small word about Suricata, what it is and how it can help you. Actually, in this three-part series webinar, we will actually try to do exactly that. But Suricata in general is a very versatile a piece of software. It is far more than IDS and IPS, although that's how it started. And if there's like one picture describing all that into one screenshot, it will be that one, I think. Basically, Suricata itself sniffs network traffic on cloud or on-premise. Based on that, it generates all different sorts of data and logs. It could be alerts, protocol transaction, network flows. You can record PCAPs, and you can do file extraction. But we'll actually be touching upon all these as we move along with today's webinar. To transfer the previous picture into reality, we'll actually do a hands-on. Our hands-on session will be exactly on that and using the data that Suricata produces in all of data to see how we can highlight some unusual or let's say bad activity based on the network traffic. You can do a lot of things with Suricata, including trainings, incident response, audit, threat hunting, network security monitoring, all that. There's different tools and distros out there based on Suricata, but the one that we use today is very easy to spin up on almost any Linux environment, as it's entirely based on Docker. We'll be demoing that a little later on as we move today. Now, what we will cover, as I mentioned, this is a three-part webinar. It's aiming at giving different lateral movement techniques for what's possible to actually detect and see with Suricata. What type of data can Suricata produce for detection? Some of the new things that are in latest at the moment 6.8.0 stable release. What we will not cover is actually, this is not meant to be a complete and exhaustive lateral coverage in all possible angles that I could take. This is made to actually give an introduction to what Suricata can do, the data it produces, and some ideas and techniques hands-on of how you can actually detect or highlight those lateral movements, and we'll cover a couple of specific cases today. Part one, just very quickly, any of these recordings actually, any of these webinars, pardon me, actually will be recorded and available. We're currently also as well live streaming. So part one actually comprises of impact of patching availability when certain CVEs come out for the infrastructure, overview of simple case usage, what Suricata can log and detect, different open source tools that you can use for the data that Suricata produces, and some walkthrough over example logs. Part two, which we'll concentrate, that's what we will do today. This webinar will actually look at specific MITRE technique, let's say scheduled task as a form of persistence or a lateral movement, if you will, and walk through some of the SMB and DCRPC logs that Suricata produces. We'll also have an overview of let's say CVE that also provides for lateral movement, and based on the data Suricata produces, what we can do to detect it. We will be creating live visualization and a hunting dashboard for those things. We will also share those created dashboards and visualizations freely open source for the community to use as well. In part three, the next webinar, we will actually see what we can do in terms of, let's say, automatically alerting or writing a signature, and do some wrap up and recommendations of the three series from these webinars. Now, what we will do today, let's just have a look at one angle. So let's say scheduled tasks, right? Let's investigate an example of how threat actors can actually establish persistence. And one way to do that is actually via the so-called technique scheduling tasks. So, and what does this actually mean? Well, it actually means that you need escalated privileges, you need to create a scheduled task, and you could do it remotely, right? So not only on the local machine, but from the local machine, if you have the privileges, you can schedule a task on the remote machine. That part actually is very relevant to networking because it happens over the networking, and that part we'll see what we can do about it. How relevant is that technique? Well, from the MITRE website, these are some of the actors and groups that are using it. It's non-exhaustive list, but it's very dominant everywhere. So some example usage by threat groups. Let's dive a little bit of our setup here. So what do we have? Well, basically, for this webinar, we have couple of VMs, right? A couple of machines. So we have a client and a server, and we have a Windows 10 Enterprise and a Windows 2022 Standard Edition. They're in an Active Directory. The Active Directory is called ST Consult or Consult. And you can see a screenshot of the summary of the Windows Server 2022. So very kind of relevant infrastructure, if you will, for us to test that thing out. And what are we going to actually use for that? Well, we're actually going to use the command line tool called scheduled tasks, or that's actually available on a Windows machine. So basically here's an excerpt of how to create a scheduled task, and that tool can actually create scheduled tasks locally and remotely on the remote machines. So what is the sequence that we're going to go through, right? So here is actually what I did on the command line. Of course, this is with elevated privileges. So the first actually command, what we will do is we'll actually ask the remote computer named DC for the main controller to list all the scheduled tasks that are there. So this is a query done from a client towards the domain control, let's say, with administrative privileges. So basically we're asking the domain controller to give us a list of all the scheduled tasks, right? The second query, or the second command, rather, pardon me, is actually creating a scheduled task on the remote machine. So what it does is exactly that. It creates a task on the PC named DC, which in our case is the domain controller. The task name is called do it. And it's actually what it will do is it will run it once a month, and it will start the execution of doit.exe, that executable. Okay, so that command for actually has returns has been successfully created remotely, and then we query the remote domain controller to list us the task, and we can see we have a new task in there called do it. And the final command that you see on my screen is actually deleting the remote task named do it. And then we have the return of success. So basically, really fast. So like we can create remotely a task and we can delete remotely scheduled task. And if not done by, if done with the harm's way in mind, it could be actually devastating to an enterprise, because if somebody gets to a privilege, if a malicious actor gets to a privilege escalation, they could actually delete or change or create their own scheduled task or whatever they want remotely. What we would like to know is, okay, so in a lot of cases, we like to understand what we can do in order to actually highlight relevant usage of that and thus protect us if there's such an attempt, let's say. There even might be an attempt and it might not be successful. We need to be able to also highlight that. So to understand a little bit better what's going on, we're going to have a quick look at the domain controller. So after I executed those commands, or when I actually created the remote task, this is what I see on the domain controller. Basically, the tasks appears in the task scheduler. It executes the first of every month and similar on. And when I look at the details, it says start this program. So it could be a regular problem, but it could also be malicious. On the endpoint, again, this is on the domain controller itself. Usually, there's a couple of ways those the tasks created would appear in the logs. Usually, they can appear two places: in the security logs as with these event IDs. In Microsoft, they have specific event IDs when a scheduled task was created or deleted. It really depends on how you create it and what tools you use to create it, as there's more than one way in some situations. But as you can see here, the other location where you could see the logs of created tasks is in the event viewer task scheduler operational. So that's where we actually see the sequence that I run on that machine. A registered task creation, registration of a task, creation of a task, deletion of a task. And the event IDs for that task schedule operational logs are actually the ones that we see on the right-hand side. As I was creating remotely this scheduled task, I was looking at what else is happening on the endpoint, and this is standard normal part of the whole procedure. We see that there is two. Remember, the remote job was called do it, right? So there is two files created in the relevant folders. So there's two places where when you create a remote task, at least in our case here in that small demo, there's two cases, two file names that appear in two different folders, Windows System 32 task and Windows task. And in one of the cases, the file is called doit.job job, and the other one is XML, or it could be. So that's what happens on the endpoint, right? But remember, we're talking about Suricata. Suricata is actually an IDS, an IPS, a network security monitoring tool. It can do a lot. So what we're interested in when we're doing that remotely, what do we see on the network? And as I was doing it remotely, I also captured the pickup, and we'll be sharing that data publicly, so that's no problem. This is a test data from our lab. So as I was capturing the pickup data there, and I said, well, let's just have a look at the raw pickup data, what's on the network. And the networks, you'll be surprised, interesting things. So we have the SMB, the DCRPC connections, and there's interesting things to observe. So, we're looking at the exact same file being created for connected to the scheduled job. And there's a couple more interesting things that we're looking. Of course, we're looking at DCRPC SMB logs because that's a remote procedure call. And we see a couple of, as I was investigating, so a couple of interesting also points or pieces of metadata, and let's talk a little bit about that as well. What does this mean? So as I was actually looking at the pickup, I also run it through Suricata. And so what do we see with Suricata? Well, just quickly, as I was testing things out on the command line, you can see some with the command line to JQ. I was actually having a quick look, and so you can see the 3 commands and the stuff they return. So basically, Suricata seems the same thing. So we have event types SMB with their relevant data. So those event types SMB are actually related to the actual network communication that happened over when I was creating remotely the scheduled task. So in other words, we have a few elements in here. So for example, we have the smb.filename piece of data, which actually displays interesting things, and we're gonna actually have a look at understand what this is and how it can help us. So it displays the task job name. We have something called UUID, which seems to be kind of very interesting. So I'm wondering, so what is this UUID? Okay, so what does it mean? Well, that's actually very common in Active Directory and Microsoft environments, of course. This is basically a universally unique identifier that actually is used for all the internal transactions for different Microsoft protocols, RPCs, and identifies it could identifies client-server interfaces and similar things. But this has a very unique value, as it shows us and it tells us different things. So, okay, UUID, we know what it is, but what does it mean? What does this number mean? In our case, I looked at the UUID, and it's very simple, Google, and this is where it came up right away. So what we see here is actually a well-known UUID for actually the scheduling service, ATSVC. And so this is the important part. This is what we're after. So we're after actually not all logs, because SMB logs and DCRPC logs could by default be very verbose, especially inside Active Directory internal communication environments. It could be really verbose. But what we're after here is that scheduled task. Okay, so if somebody schedules a task and they're actually not expected or allowed or to do so, what would that be? And that's meant to mimic all different sorts of scenarios where somebody would use the SMB to kind of move laterally or to set up a malicious task laterally. And looking a bit more, what do we actually see with Suricata? So this is actually an SMB log from Suricata while I was inspecting traffic. And we have actually the task name with the folder name where it was created for. This is actually the scheduled task. And we can see it's a file create in this position, meaning like if there's no such file created, in other words, it does create the scheduled job. Status is success, and of course, as I mentioned, the event type is SMB, right? So what can we do the network side and how we can actually zoom in on things like that or search those occurrences. So what I'll suggest is, so enough with the jibber jabber, and let's get some hands-on and try to figure out and understand what do we have in terms of data that the Suricata produces and how we can do some useful visualization or a combination of queries, let's say, to figure out one out. All right. So first of all, I'm going to switch on to my demo now. Hands-on. What I will use is I've used exactly these 4 commands to set up my test environment and to read the pickup that I've actually created. Basically, you can run this on any Linux distribution. It presents a bunch of tools that are for hunting, for visualizing Suricata data. Any and all data is produced there from Suricata. It has a bunch of other open source tools in there, like the Elk Stack, Archimate, Sirius for hunting, EveBox, which is also made from one of our colleagues and developers from the Suricata team, Jason Ish. And so this is all bundled in together, and that gives me a lot of firepower in terms of all visualizing and making sure I can see any data I want. In this case, what we'll do is actually we'll zoom in specifically in Kibana and try to create ourselves a dashboard or hunting, some hunting visualizations to highlight that. Okay, so we want to highlight when something creates a scheduled task remotely, because usually this requires actually escalated privileges. We want to know about that, and we want to have traceability, let's say. All right, so in this case, so let me move to what I will do here is basically I have my environment set up and ready. I will basically run a script ingestion command. And so let's see what this will show us. So in other words, I have the 4 commands previously on the previous slide executed on the Linux. This one is, particularly is Debian. So I'm just going to run the read pickup task now. So what this will do is basically ingest the pickup that I've captured while creating those specific queries, deletion, creation of the scheduled task. So I'm going to run the script. Basically, it will ingest the pickup. So it will clean any and all previously data in there. So we know it starts from 0 from scratch, and we're just going to zoom in on that specific case and see what we can do about it. So let's go ahead and give it some time. So what this will do is actually load Suricata, read the pickup, and that's it. We're kind of done. So as this is already up and running, I will actually switch into the login interface. The default password is as Selx user, but as you can see, it's actually basically running on HTTPS localhost, so it's very easy to spin up and spin down. So this is basically the Sirius Security Platform open source edition from Stamps Networks that comprises a bunch of other open source tools to visualize all the data. Username and password defaults are Selx user. We log in and we're presented with a landing page. We have basically a switcher application on top here. We can do a few things, go hunting, go with the administration, or visit one of the external apps like Kibana, EveBox, or CyberChef. For our purpose here, I'm going to zoom into Kibana. And actually, what we have here is already predefined and pre-built about, about 28 dashboards ready to use for all the data. In our case, I will concentrate on the SMB, as this is SMB that we are investigating. I have 0 data because actually the pickup was created on Monday, I think, so I have to reverse back a little bit. All right, so we have a ready to use and freely available open source dashboard here. And you're going to have a link to all those in my last slide in the webinar. I can answer any questions on the Q&A as well. So we have a dashboard here that we can use. It's called SNSMB. This gives us basically an overview that we have 114 SMB logs in here. So this specifically concentrates on the SMB, so no other data. So like no alerts, no HTTP or DNS. This is just SMB data. And this is a good start, but we're missing a few things. We want to refine it a little bit. So what we have here is basically source, destination IPs, and similar things. We have some SMB specific stuff like client dialects, status codes, Kerberos hash names, and similar things, functions if available. If there's some data missing, it will just not be displayed. Funny enough, we have in the file names, actually one thing that we see is basically the do it job. And here on the bottom, we basically have all the logs themselves. And this is, so for example, if we go to a JSON document, if I click in here, so this will be the actual complete JSON document that Suricata produces. This will be like the SMB data. We'll have other information in here like flow ID, the status keywords, anything related to the SMB, basically to the SMB log, and it could be quite verbose. There's a lot of information in here. So I am actually going to go back here because that's not. I just wanted to show that as an example. So we would like to understand a few things. So first of all, when a remote job is created, is basically, apparently in this case, in our case at least, it has a name and it has a .gob extension, let's say. Okay, so this is basically creating the job itself. But we really want to zoom in on the case where it actually doesn't list the date, where it actually creates it, for example, and on the networking we might have hundreds or thousands of these cases, and even just millions of regular SMB logs. So we need to be able to actually, from this, create some sort of a query or a filter and zoom in when we want to, and just on those specific occurrences, right? So as you can see, the logs here are very verbose. We can relate and correlate different information, and we're going to get there in a second, but let's see. So what we want to do is, as we said, let me go down here. So we're kind of after where the file name, for example, kind of resides in a specific folder and has a specific extension, let's say. So in our case, in our test here, what we did was, create a remote scheduled task, and we named it do it. It resulted with this file name as default settings on the Windows 2022 server, which was also domain controller. So we also want to make sure, as on our one of the previous slides, that is actually it's created, right? We want to make sure we can zoom on that. So let's go have a look. So I'm going to come in here, and actually I'm going to do so smb.filename. I need to wildcard it, and in our case we're going to use Windows. We need to escape one of the slashes, tasks, and we have a couple more backslashes to escape one of the regular folder structure name. And here I would like to search for that. So for example, this will give us, hey, give us a list of all these things happening. So let's see what we have here. Okay, so this query returns 10, but I don't want 10, I want the 1, because this is actually could be related to, let's say, just listing or querying a remote job. It doesn't necessarily mean creation. As I scroll down here, I can see, yeah, okay, so this gives me a list of all these things. And excellent, good enough. But, I was... also, I also had this wildcard. So, okay, it will give me any name of the job where it was created. But I want to zoom in specifically on where the disposition, remember, when we look at disposition, is create. For that, I can simply actually add a filter through here, select this position. This is from the data that Suricata provides. And I'll say where the disposition is. So there is two options, I think, here. Oh, did I? Let me see. Is it? Yeah, so the disposition is file create, right? So in SMB, so I'm going to go in and save that. So this will be my combination. So now I'm down to one. So basically, I want to see all the jobs in the network today done by SMB and with when it was actually created. And this will give me, from all these 140 logs, will get me down to that one log here, which is the actual SMB log produced by Suricata. I can also do a lot of things. I can simply correlate a flow here, and this will make me jump into Evebox. And here, basically, that I'll have the full conversation based on flow ID from Suricata. The full thing from login to log off, and that job creation, including the file transaction of the actual file itself, if the file transaction itself as well. Everything from login to log off, like a full-blown a conversation, if you will. Anything with flow, SMB records, and as you can notice, there's no alerts here. It's just file information, basically network protocol logs. And any of these could actually be very verbose and have all the information that you need with chars, with checksums, sizes, file magic, and similar. Now, this is all great. So what I want to do about that, what I would like to do about that is actually save that query, so I don't have to type it every time. And so I can come up here. I have some previously saved queries as part of the default setup here, which is open source, and you can grab it from GitHub anytime you like. So I'm going to save the current query. I'm going to include the filters. So this will should give me that filter and the query itself. And for a name, I'm going to put scheduled task creation query, let's say, and just come out with it like that and save it. So this would be my query saved. So if I actually remove all these things, so let's see if it works from the save query. I'll come in here and I'll have my scheduled task creation, and now I can click on it and I'll zoom in on it right away. So one way to actually detecting and zoom all those things. So things that you should be actually probably looking in here is basically, okay, is this IP, let's say, expected to come in? Is this IT admin part of networks that is expected to do that? Is it unexpected? Usually on critical service infrastructure, you would not have that many of these occurring, so it could be really easy to check and see those things. Now, this about solves one part of our querying and part of what we want to do, and in terms of actually searching, because again, it could be millions of logs. We need to zoom in on those relevant ones themselves. what I would also want to have a look is, remember during the presentation, we were chatting a little bit about UUIDs, unique identifiers. So I don't have those here, but I want to restructure this piece a little bit, and I want to actually, have those added in. So let's see what we can do about that. For that purpose, I'm actually ready to use, let's say, Kibana dashboard. I'm going to go and click the edit button here, and I want to create a couple of more, if you will, visualizations to display those things for me. So in other words, okay, so let's say I have these things, so I just need to create a simple one. I'm just going to click the create button. I'm going to choose a table just because it's easy enough. I'm going to choose a index, or in this case, like a protocol that I want to work on with. And in our case, this is all SMB logs usually go into the log/SMB index in the open source SOX installation that we have here that is ready to use. So I'm just going to zoom in on that. And now this is done for performance purposes. And now I have the available fields here, so I can just simply drag and drop. What I'm interested in is, as we said, the UUID, so I can just drop that in here. And so that immediately gives me two unique ones happening 3 times. In bigger networks, let's say you might put number, so the number of lists it could be, let's say, up to 50. I can click refresh, and so basically this is all I need. So now I would actually basically click save and return. And my visualization, let's see, is on the bottom here. I would love to give it a name. I forgot to do that. So here we will say SMB UUIDs. Okay, so unique identifiers. So we're going to name it like that. And I'm going to bring that more up to top, if you will. So I'm going to put it somewhere in here. Now, we have some of the UUIDs here. So let's have a look quickly at one. So let's have a look at this one. When in doubt, I said, you're always wondering what's what. But we can go ahead and, not this one. I was actually wanting to do this one. So what is this? What is this UUID? In other words, that returns something interesting. Let's have a look. Well, this is actually the UUID for, as we saw in here, the scheduling service itself. And we can also, this is the SA-sec. We can go click there and see what we have. And what we have here is, Microsoft documentation. So what we have here is something very interesting. So now, there is something interesting here. It shows option numbers. In other words, this UUID goes with specific option numbers, and they differ for any specific different protocols. It could be hundreds and 1,000 different combinations, similar. But we have different option numbers in here. So I wonder if we can maybe have, if we have the UUIDs, I wonder if we can maybe have the option numbers in here as well. So let me go check that one. I'm going to quickly go and create another visualization here. Again, we're going to use a table. approach. Have the SMB data here running, so I can choose anything you want, but SMB data is what I want. And I'm going to scroll down in here and see what else do we got. And sure enough, we have the actual, from the SMB logs, we have the option number. Oh, that's not how I want it displayed though. So let me quickly fix that. Not the mean. I will do. Yes, so we want a table and the DCRPC option number. We don't want that. We want. Okay, so we will not be building on timestamp. We will be building on. We want the option number itself actually. And we want, yeah, I can close that. And so instead of here, we want basically a count, a simple count will do actually like that. Yeah. So basically we have the different option numbers that we've seen and how many of what we've seen. So these are not specific for UAD, but in general, all of them. So I'm going to save and return as well. And this would probably end up on the bottom here. I'll need to name that as well. And I would name it option numbers, basically. Put it in here. So let me move that up a little bit. So let's see where we're at. Okay. So, okay. And here we have it. All right. So now what this gives me is basically, I can mix and match. I can pretty much click on here and then chase specific UUIDs, let's say. And so this is kind of very helpful for the different parts and situations. And also, I can also would like to see if we can add a couple of things in here. So like when we're looking at the logs, we actually have a couple more columns. So for that, I'll simply click on the edit search button. I'm going to go over here. And so there's a bunch of fields that I can add, but I said we actually needed, what was it, UUID. So let's say I wanted to add the UUID, I wanted to add the option number, and I wanted to add the disposition, right, as we were looking through the slides in here. Okay, so let's see. Okay, so now we have basically UUID. If it's there, it will be displayed in that specific record. An option number, if there's any option numbers, we'll actually see them in here, which is great. And then we will have the disposition file open or create if it was. So that's great. So let me go ahead and save that. I'm going to save the search. I don't need to save this as a new search. I'm just going to click save. All right. So now I actually would basically go back to my dashboard in here. And let's see. We have all these things populated in here, so that's great. At the bottom, I'm going to go ahead and save it. And the dashboard will save. So now actually I have my dashboard. I have created a hunting query, if you will, that could be engaged. It could display me exactly what I want based on our previous test. And also, I've added a couple of visualizations here. One is actually listing the unique identifiers, and the other one is actually listing the DCRPC option numbers that we have. So we can actually freely zoom on a specific option number, and that will give us where we've seen that option number from all different UUIDs, or vice versa, which makes things a little bit easier to zoom in. And as we said, this actually here was one of the UUIDs for the scheduling service. So I can actually zoom in on that as well, and actually give it, I think, a custom name. We can actually say, I think that was the correct name. Maybe I didn't did it correctly with all the right things here. Let me do that. So I can actually save that. So there is another query saved in here that I can actually easily zoom in, and I can say temporarily disable. So this will be temporarily disabled. And when I want to enable and look at this specific part of scheduling the tasks, I can actually re-enable it. And that will zoom me exactly on the two logs where this UUID was used. So that's also another way to use it. I'll temporarily disable it because I want to see all the data. And you can further on as well go in and save the visualization, the dashboard, pardon me. Now, as I mentioned, if we scroll down, we have also a couple of other interesting things. So we see we have file names like WinReg and AT services. This is basically when certain tasks can actually leave over to other protocols or other, in our case, identified by unique IDs, in our case, different UUIDs, and that's what happens here. Actually, a scheduled task could use actually different further remote procedure calls, and those already have some default names. Our custom created job is this one, and in the logs in here, we actually have, for example, the file name, if that was created, or SMB, protocol specific information related, of course, UUIDs, option numbers if they exist, and disposition. So as you can see, this the logs could be very verbose, but what you would be interested most of the time is actually basically your saved queries, the UUIDs, and similar things. So now, armed with that information, we've actually created a couple of new visualizations. We've enhanced one of our searches, which is at the bottom of the dashboard. We saved the query, and all inside really 10-15 minutes. It was very easy to actually work, in this case, with Kibana and all the data that Suricata produces from the SMB protocol logging. We can do similar things in other, let's say, databases and search engines and CEMs, Splunk, Chronicle. It doesn't really matter because the data is there. It's standard JSON format. I wanted to quickly review, armed with that information, I wanted to actually run another PCAP here, and this PCAP was called, the printing nightmare, which was, something happened last year, the so-called printing nightmare CV book. So I'm just going to run it and see if that could be helpful for my with my uncovering with my visualizations. And just a quick look. So yeah, basically we're ingesting the PCAP here. There's going to be some regular info messages and similar things. And so let's see. Then after it's done, we should have signal receive stopping engine. So going back on my dashboard here, of course, now if I let's say refresh there's going to be nothing there because I need to zoom in. This pickup was actually down created. I think it's public. Down created last year. So let me update in here. Okay, so we have 18 logs. And if I have a look, this is actually the printing nightmare, the CV, specific CV bug with Microsoft. And this is a specific case. So what I'm looking on is actually, we have that specific UUID with those option numbers. And so if I actually come in here and I want to specifically, which, oh no, that's, I did a wrong copy paste here. So let me see if I zoom in like that. So as you can see, this actually comes in directly with print system remote protocol. Which is actually great, and you can also see that if I log in the server details, message processing sequences, I should have the different option numbers named in here. There is a reference, of course, and that's more easy to click and find the things. And there's different option numbers here. So what this tells me is like the printing protocol was in use, and we have option number 10 and 88. And if you look at 10, basically it's enumerating printed drivers, but what is more interesting and valuable in our case, let's see, 88. Basically these two parts actually has to do with actually changing the printed driver. So which was basically one of the problems there. So an easy way to kind of figure out, and you can actually also zoom in like so on the dashboard, and in here you can rename it, and you can also say in filter, you create a custom label, and you can say printer UID. So let's say something like that. And that will actually show you any information related to printer queries, changes of drivers, and similar things that that actually happened over the network. And very easy to zoom in on those details. So you can switch it off. Again, in our case, it was the option 88. And those two options were used 10 and maybe 18 hour pickup here. So very easy to zoom in and see what happened from where and when. That's about it, actually, what I wanted to quickly show here. And hopefully it's useful. Hopefully I managed to packing enough firepower here, enough data, so it could be, so you can actually try this at home or your corporate networks. Again, these all the tools in here are basically, let's see, basically free and open source on GitHub. Celx and Sirius are underneath the Stamos Networks repo. We have over 400 different visualizations and dashboards ready to use for Suricata, any Suricata installation, as long as you have the aux stack installed. Evebox is out there. If you want to contact them, please feel free. But most importantly, the forum is out there for anybody to join. And we, of course, have one of the biggest things coming up for us every year, which is the Suricon in Greece. And so I'll be more than happy to see you there. And I'm actually available for any questions or anything that I need to. We're more than happy for anything that I need to explain again. Open the questions here now.
Hey, Peter, we have a couple of questions from YouTube.
Okay.
So first is, both are from Slavomir Klobuzovsky. I'm sorry if I mispronounced your name. How do I set up DC to be accessible from an endpoint?
If you're referring to actually the setup that I have, I haven't done any specific setting up. I just had one server as a domain controller and one virtual machine as a client, and combine them into Active Directory. That's all I did. I wasn't doing anything more than the usual default setups. And when I actually when I actually did schedule the task remotely, I recorded all the traffic, and that was what was available on the network. So I haven't done really any customization much apart from the default settings.
Okay, we will see if that answers the question. There's a follow-up question for that, I believe. Where do you typically deploy Suricata in the network? They believe that at the endpoint is not the case.
Oh no, not at the endpoint. Suricata is a sniffing software, so it can passively or actively. It can be deployed passively or actively. In our case, it was passively. So the passive one is IDS or network security monitoring mode. The active one will be an IPS security mode. In one of the scenarios, it will sit in the middle of the traffic and it will allow traffic in and out. That's the intrusion prevention system, IPS mode. In the other case, we will passively sniff the traffic and generate all those network and protocol logs. Usually we'll deploy, sorry, I forgot to mention. Usually we'll be deployed like depends on the internal networks or on the edge, depends really on what your architecture is, but usually how it's deployed is you mirror traffic off a tap or a switch port onto Suricata. So it's a very easy way of actually getting a huge observability and visibility right away with very little effort, as you don't have to actually go in and specifically install it on a number of endpoints. It's just one place. It's a very cheap and good way of providing visibility or any threat hunting audit, similar things like that. I hope this answers your question.
We'll see. Now we have one that comes both from this same person and from Vagisha. They want to know where can they find the PCAPs to detect lateral movement exploits for Microsoft, and also the scripts that effectively load the PCAPs, where they can find that. I believe you said you would share everything.
Yeah, so this is basically the 4 lines that will get you up and running. We will share the PCAP and right after the webinar. So today or tomorrow they will probably appear in the link on underneath the webinar itself on YouTube and all that. But this is all again public data, so lab data. So there's no problem sharing. And this is the 4 commands that I used to bring the lab up. Very easy. That's exactly what I did. Everything was packaged in there. Any Linux machine. It's Dockerized, so it has a Suricata in a Docker, the Elk stack, the Sirius for hunting from Samus Networks. It has Evebox in a Docker as well. Everything is just packaged and ready to go. And the last command is really what I did in the test. I have everything set up, so that's basically it. And you can find these things on GitHub, and I've put the links exactly how. So we will update. There will be a recording of this available on YouTube, of course, as well, and we will update there with the link to the PCAPs and the tools themselves. Yeah.
Awesome, thanks. One last question. Let me find it. What are the best resources to use when I am not sure what operators will get a SIG build? I use the Suridocs a lot, but are there others? That was asked by Colin.
Okay, can you repeat the question one more time? I did not understand or hear the first part. What was the...
What are the best resources to use when they are not sure what operators will get a SIG build? I think they are trying to understand how to better write a signature?
Okay. So always go to read the docs Suricata online. Always consult that. The next webinar will actually be concentrating on how to write rules for a couple of other CVEs that engage with lateral movement. And we will post also lots of links there to freely available resources. But always go to the online docs for Suricata, consult the latest docs. And when in doubt, we actually, there is a Discord channel for Suricata that you can actually log in and basically jump in, discuss any question. This is available from our website. If you go on suricata.io, you have how to contact us and all the links, and there will be a Discord link in there. You can jump in and get live chat with any of our community members or developers. There's always somebody in some time zone that is willing to help. No problem. And also the forum, Suricata forum. There you can actually post a query, question, and it's a great source of knowledge because there's a lot of users there that I'm pretty sure there's always somebody that has probably done something like your question needs for, and so there's always some sort of an answer. So those three.
Sorry to interrupt. I also would like to add 2 other resources. One is the Suricata rules language server developed and written by Eric Leblanc, right? That could help you a lot.
Yeah.
It's also open source, so you can find it on GitHub. And what I like to do, I'm not a rule writer, but when I have to do Suricata verify tests, for instance, what I'll do is I'll check the tests that we have in Suricata verify, and that will have lots of examples for rules because many of the tests do have rules there. So sometimes I'll do a git grep and find the rules and see if I have the keywords that I want. So yeah, sometimes that helps as well.
Right. Excellent. Thank you very much for all these. Any other questions left?
I can't see any. Nope.
All right. Okay. Well, hopefully this was useful for a lot of people. It will be, of course, available online, and be more than happy for feedback, criticism, any suggestions. And please look out to Suricon. Join us there if you can this year. And looking forward to webinar number 3 as part of this lateral movement webinars. Thank you very much to my teammates, Juliana, Dave, Shivani, that are actually here supporting and always helping out and have actually a good part of making this webinar happen. So thank you, guys and girls, much appreciated. And thank you for all the people that actually are watching this or will watch it and have questions. Much appreciated.
Thanks for the webinar as well. We had Josh join us, and I think we could plan another webinar with him now as a guest.
Absolutely, sure. I'll be more than happy to. Yeah. Definitely.
Someone is asking for Twitter pages. I'll share that on the YouTube channel in a bit.
Yeah, sure. Thank you very much. Much appreciated. Absolutely.
I think we are good.
All right, excellent. Thank you very much for your time once again. Thanks, Jules. And we will see you folks later then. Much appreciated. Ciao.